All right, guys, how we doing? Taking a look at, again, some of the questions you guys have had on 9-7, those two shortcuts, difference of two squares and perfect square trinomials. Taking a look specifically at some of the questions that you guys had. Right now we're going to take a look at question 48. 48, I think we got a grasshopper. So 48, a grasshopper jumps straight up from the ground with an initial vertical velocity of 8 feet per second. So first it says write the equation for the height of this grasshopper. All right. So again, this is a vertical motion model. So we're going to start with that and fill in what we can. Let's fill in what we know. We're not sure about the height yet. Okay, negative 16t squared plus the initial vertical velocity, I think they told us was 8. So that's 8t. And this grasshopper was jumping from the ground in this case. So its initial height or its initial position is 0. I could put that plus 0 there, but I really don't need to, nor do I want to. So I'm not going to. You can't make me. So here is part A. All right, there's the equation that we're using in part A. All right, that we can find the height of this grasshopper by doing negative 16t squared plus 8t. If you tell me how long this grasshopper has been in the air, I can plug it in there for t, and I can tell you how far off the ground this grasshopper is. All right, which kind of leads right to part B. It says how long is it going to take this grasshopper to get 1 foot off the ground? All right. So let's look at how we might solve this thing. All right. So again, I've got my equation there that gives me the height, and they want to know when is that height going to be 1. All right. So this one's again a little bit different here. It's not when does it hit the ground. Normally we've done these before where the height is 0. But in this case, they want to know when is that grasshopper going to be a foot off the ground. Okay. So here's the equation I want to solve. Now I've talked about this before, but this is a really good example of it. So thank you for whoever asked this. It was Aubrey. Thank you, Aubrey, and quit apologizing. Aubrey, oh my gosh, she had the nerve to say, "Hey, could you do problem 48? If you can, it's no big deal." Right? Like I'm not going to do it. All right, seriously, get a grip, Aubrey. All right, but no, Aubrey, thank you for asking about this question. So here's the equation I want to solve. Now, again, I've mentioned this before. I want to get this thing equal to 0, and a lot of you might say, well, let's just subtract 1 and get it to 0 that way, and that would be fine. But I've mentioned before that I like my squared thing to be positive, all right? And right now it's a negative 16t squared. It's a lot easier to factor when that thing is positive. So what I'm going to do to get this to 0 is I'm going to add 16t squared, and I'm going to take away 8t from both sides. So I'm going to come over here, and I'm going to add 16t squared, and I'm going to take away 8t. I'm going to get my 0 over here, again, simply because right now my squared thing is negative, and I'm not used to factoring it that way. I want to get it how I'm used to seeing it, all right? So write things in the correct order. The highest power to t first, and then minus 8t, and then plus 1, and now it's equal to 0, okay? So now that I've got it equal to 0, all right, to use my 0 product property, I've got to write this as a product. I've got to factor this. And again, this is not a difference of two squares because I got, 3 terms, all right? So this is that perfect square trinomial. So as I start looking at it, 16t squared, yeah, that's 4t and 4t. 1 is a perfect square. That would be 1 and 1. And if I multiply those two and double it, I get 8t. All right, so yeah, this can be factored here. It's 4t. Again, remember that sign is going to agree with that. 4t minus 1 and 4t minus 1. And again, I mentioned this in one of my other videos. You might see some people write it as 4t minus 1 quantity squared rather than write it twice. But I write it twice because that's what we're used to seeing. Okay. So now I'm multiplying two things and getting 0. Now again, this happens to be the same thing, so I don't need to write this twice, but I know that 4t minus 1 has to be 0. So now I've got a two-step equation to solve. I add 1 and add 1. I get 4t equals 1. and then divide by 4 and divide by 4, I get t equals 1/4. And again, I think I know we're talking time here and we're talking seconds. So it's going to take this grasshopper about 1/4 of a second before it's 1 foot off the ground. Okay. So again, just a couple things that I think you needed to catch on this to have some success here. First of all, recognizing that was a vertical motion model, recognizing that S was 0. This grasshopper was jumping from the ground, not from a picnic table or anything. So S was 0 here, and then we wanted to set it equal to 1 this time, not 0. All right. If we would have been asking, hey, how long is this grasshopper going to be in the air, or when does this grasshopper hit the ground again? Then we'd fill in 0 here. All right. And we could do that if you want to do that. If you need some extra work, go ahead and do that. But we set it equal to 1. And then the other thing, getting this equal to 0 by adding 16t squared to get that over here. Because again, then it's positive. And if my squared thing is positive, it's just a lot easier for me to work with. All right. Okay. Hopefully that helps. Again, this was question 48 on 9-7. Hopefully that helps, guys. Take care.